Okay, hi everyone. So today we're just going to be going over the introduction to pandas for Module 2. So I'm just going to be going over the presentation, and then in addition to that, I'm going to be also going over the live examples through the collab as well. So if you're going through the notebook, I would recommend just following along with the presentation, and if you think it'll help you, also opening the collab notebook in another tab so you can follow along with examples. All right. So let's get started. So first off, Introduction to Pandas, Module 2. So starting off, Pandas is an open source data analysis and manipulation tool. So basically what that means is it's a software library that's been built on Python, the coding language that we went over in the past module. And it basically allows us to analyze data and to draw conclusions and look for patterns within that data. And it's used a lot in both academia, so in universities for research, as well as industry, when people are doing data analysis for projects or that type of thing. It can really be used for like a lot of different projects, so there's a lot of different possibilities with pandas. So it's a really useful library to know, and that's kind of why we're going over it today. But yeah, so in order to understand pandas, the first thing that we have to kind of get is the types of data structures that are present within pandas. So there are three types. The first one is series. So that's kind of like a one-dimensional table. So for example, here, you can see that in the table, there's days, as well as the data for growth of a plant, for water and water plus fertilizer. So a series would just be like the table of days. So it would just be 1 through 5, and there would be no other dimensions. But by comparison, a data frame would be kind of like what we're seeing here on the side. It's a two-dimensional data structure, so it's basically going to be your standard data table and probably the most familiar data structure, and you're probably already going to know it. And then finally, the third type of data structure within Pandas is a panel. So it has 3 dimensions, which basically means that it's actually made up of other data frames and then one other variable in order to make this third type of data structure. Within Pandas, we're mostly going to be working on data frames. So we're mostly going to be working on data that has these 2 variables and basically looks like a standard data table. So you don't necessarily have to be super familiar with panels or series, but just it makes sense to think of all of your data tables as data frames, since that's going to be how we're going to be referring to them as we use pandas. And then within the module, as we test out and kind of go through all the different features of pandas, we're going to be using one data set that's basically a data set showing all of this information on passengers on the Titanic. So it's going to include a lot of different information in there, but it's going to have a list of passengers and their names, what passenger class there were, if they had parents or children aboard, etc. And then using that, we're going to use pandas to draw some conclusions about what type of passengers were able to survive the Titanic, as well as what type of passengers were actually aboard the Titanic before it sunk. All right, so to get started with pandas, the first thing that we're going to have to be familiar with is how to import pandas and how to actually get the library in there. So in order to do that, we're going to be using a command called import pandas as PD. And basically what we're doing here is that we're taking the pandas library, which is called pandas, and then we're importing it as a specific name. And general convention means that we're going to import it as PD, like just those 2 letters, but you could technically import it as anything. Like you could import it as the word pandas, you could import it as a random word, but in order to make sure everything stays organized and you know what all the different names of things in your code is, generally it's just a good idea to name it PD. So as you can see here, what we're going to do within the Colab notebook is basically just run that one command that says import pandas as PD. So down here, there's this one command that says import pandas as PD, and we're just going to click the play button within the Colab in order to run it. And then once that's done, then what you've done now is that you've imported this whole software library with all these different commands and functions for data analysis called Pandas, and you've given it the name PD. And now anytime you reference those two letters or that name PD, you're going to be referencing a command or a specific function or a specific feature within Pandas. And by the way, if you have any questions, feel free to put them in chat or just verbalize them out loud if you're within the studio. But just feel free to message them in chat as I'll be able to see them. Or if you just want me to slow down, that's also totally fine. All right, so once you've imported the Pandas library as PD, the next thing you're going to do is load your data set. So in this case, you can see within the collab, we're just using a data set that's from one of our GitHub files, but this really can be any URL. That could be something within your own files, so a data set that you have on your computer, or it could just be another link to a data set somewhere else on the internet. But all you're going to do is you're going to set the variable URL to equal the link of your data set, and then you're going to create a new data frame by using PD, referencing pandas.readCSV, and then within parentheses, URL. So basically what you're doing here is once you've created URL to represent this link you have that links to the data set, you're going to use the readCSV command to access all of the data within that link, and then it's going to create a data frame, and it's going to create it based on the name df. So once again, you could name this anything. For example, you could name it like Titanic underscore dataset or like dataset underscore one or any of that. But since we're just using one data frame and one dataset throughout the tutorial, we're just going to name it df by default to represent data frame. But once you've done that, you've basically told Pandas to read whichever files at this URL, and then all of that info is going to be assigned to this name df. And then once that's done, and once you've ran this code block, when you call df again, you'll see that it pulls up this data set. So it's going to show all the information within the data set based on your link, and it's going to arrange it as Pandas does within this data frame, which is basically, as you can see, a data table. And then now, whenever you do any other functions within Pandas, all you have to do to access the data is just call the name df and you'll get your data. So now that you've done that, when you call df, you will see a data frame like this. Or again, if you're using another URL and you call df or whichever name you've given your data frame, it's going to display that once you call the name. All right, so now that we've understood kind of how to load a data set and how to get started with just viewing the data set within Python, the next thing that we're going to learn is how to collect basic information about your data set. So the first thing that we're going to learn are these two functions called head and tail. So the first one is df.head, and that's just going to give you the first 5 rows of your data set. And then the second one is df.tail, which will give you the last 5 rows of your data set. So as you can see, when we call data frame, it actually has 891 rows and 12 columns, which means there's 891 different passengers within the data set. And you can see all their names here. But since obviously that's a lot of passengers and a lot of data to work with at once, one thing that you can do when you're starting off with going through a data set is use the head and tail functions to kind of get a picture of what types of data is available within your data set. So in order to do that, you're just going to call the name of your data frame. In our case, it's df, but remember that it could be anything from like dataset underscore one to any name that you can think of. And then after the name of the data set, you're just going to type .head and then parentheses. Once you do that, and once you run your function, you'll get back the first 5 rows within your data set. And as you can see here, this shows us the first 5 passengers. And then basically, you're just going to do the same thing for the tail function. You're going to have the name of the data frame or data set you're working with, and then the name of the function you're working with. In this case, it's tail. And then once you put them together, you get the last 5 rows of the data set. You'll also notice that within the data set, there are some different types of data available to look at. So the first things that we're going to have here are going to be pretty self-intuitive or pretty self-explanatory. So we have whether or not they survived, 0 being no, that they didn't survive, and 1 being yes, they survived. P class is passenger class. So there's going to be first class, second class, and third class. You have the name of the passengers, the sex of the passengers, the age, as well as SIB, SP, and PARCH. So SIB SP means the number of siblings and spouses aboard the Titanic, and PARCH means the number of parents or children aboard the Titanic. And then right next to those variables, we also have ticket. So that's basically kind of just like their ticket number, or whichever their ticket read, fare, so how much they paid to board the Titanic, and then their cabin number and which port they embarked from. And when it comes to port, there's 3 options. There's S, C, and Q, and each of them are just different ports. So S is Southampton, Q is Queenstown, and C is Cherbourg. I don't know if I'm pronouncing those right, but yeah, they're just 3 different locations that the passengers could have boarded from. But yeah, in summary, just use these functions to get the first 5 or last 5 of your data set. All right, so the next function we're going to learn is the info function. And basically what the info function does is, using the same format as the previous functions we learned, we're just going to get all of the basic information regarding what the columns of data are, and also like how much information is actually available from those specific columns. So as you can see here on this slide, there's a screenshot of what happens when you call df.info. And it'll tell you all the different column headings, so all the different type of data available, as well as this thing called non-null count. And basically what non-null count means is non-null means that for this specific column, it's not empty. So as you can see, when we went back to the data set, we saw earlier that there were 891 passengers. So that's a lot of data. But there aren't values available for every single type of data within the data set. So for example, as you can see right here, when it comes to cabin, within the first 3 rows right here, only the second row here for passenger John Bradley and Florence Briggs, this one here, has that cabin information available. Her cabin was C38. But the rest of the first 3 passengers just don't have that information available. So what non-null count is doing is it's basically counting how many times there's actually information available within that specific column. So as you can see, for passenger ID right here, for passenger ID right here, you can see that there were 891 non-null values. So there's actually information available for passenger ID for all of the passengers on the data set. You can also see that, for example, for survived, you have that information for all the passengers. For every single point or every single passenger in the data set, we have information on whether or not they survived. But you can also compare that to something like, for example, age. We only have 714 non-null count, which basically means that we actually only have the ages available for 714 passengers instead of all of them. And you'll see for the most part, you have all the information for most of the types of data or most of the columns. The only ones where you have a significant amount of data missing is for age, where only 714 passengers have it, and for cabin, where only 204 passengers have it. So there's some missing data, especially when it comes to cabin. In addition to that, next to non-null count, you also have D type, which is basically data type. And basically the types of data are float, 64, which is just going to be like floats or numbers with decimals, int 64, which is just going to be whole numbers like 1, 2, 3, etc. And then finally object, which is basically going to be strings or like any type of text or anything that is in numbers. And as you can see, when we go back to the notebook and we run the dfinfo function, we'll see that it basically gets back the exact screenshot of what we saw within the slides. It has all that information about the columns, how much information is actually available for each of those types of data, and what type of data you're actually working with, whether that's whole numbers or ints, decimals or floats, or objects, which is like text. So after that, once we've learned the info function, we're also going to learn the describe function. And the describe function is going to give you a bunch of summary statistics about all the different types of numerical data within the data set. So kind of related to what we just learned, when we look at the info function, we can tell that a lot of the actual data available works with numbers, and then a small portion of that is like stuff that can't really be calculated and isn't numbers, like name, their cabin, or their port. But all that other stuff, you can do things like calculate average, you can calculate the minimum, or the value for 25th percentile, the maximum, all that different stuff. So what describe function does is it's going to put all that together and then show you all the different summary statistics for that numerical data. So for example, here we can see under df.describe, once you run that, you're going to get all the different summaries. So for example, you have count to give you the number of non-null values, even though info function kind of already did that. The mean for average, standard deviation, minimum, and the values for 25th, 50th, and 75th percentile, and then finally max for the maximum value. So this function is particularly useful just because it'll let you get a kind of summary of all the different numbers in the data set and kind of like garner what type, like, or garner kind of like the overall picture of the data set. So as you can see, like an example of how that might be used is if you use the describe function here, you can look for the average of survived, and you can see that 38% of people survived within the data set. You can also see, like, for example, the average for age, and you'll see that the average age was around 30 or 29.699118. So yeah, using the describe function will give you some basic summaries of the numeric columns, and you can kind of get a general picture of the numbers in your data set. Once again, feel free to tell me to slow down if you think I'm going too fast, or if you have any other questions, feel free to join the StreamYard or just message them in Twitch. All right, so next we're going to learn the shape function. And this one's probably going to be the most simple of all of the functions, but you're just going to call the name of your data frame, in this case df, and then also use the shape function, and you're going to get the number of rows and number of columns. So as you can see here, you just have to do df.shape, and then you'll get back 891 for the number of rows and 12 for the number of columns. It's kind of like the most simplistic function of all of the bunch. And you'll also kind of realize that you're probably not going to use that one as much just because the other functions will probably give you more information as well. So like, for example, for the info function, it kind of gives you a better picture of what the data set is going to look like. And when you call actually the name itself for data frame, like right here, you'll see that at the bottom, it automatically tells you the number of rows and number of columns. But shape is also good to know. Okay. And then, so yeah, those are the basic 5 sort of functions that you're going to need to know when you are trying to figure out a general picture of your data set. When you use all of those together, you can kind of just use them when you're first loading the data set, and then you can figure out what types of data is within your data set, how much of that data is actually available for all the different columns, as well as some like summaries and general picture of what different variables are within your data set. And in our case, we now know that there are 891 passengers, that, for example, the cabin type of data is not available for all those passengers, as well as some of the average values for variables like survival rate, age, number of parent and children, the fare that they paid, etc. Once you've kind of gotten that basic picture, like understanding your data set stuff out of the way, the next thing that we're going to learn is how to actually work with the data set and how to manipulate that. And the first thing that we're going to do when we do that is to learn how to set an index. So as you can see, when you start off loading your data set, you'll see that automatically there's going to be a huge row of numbers on the side. So you have 0, 1, 2, 3, 4, and that actually keeps going all the way until the end of the data set. So as you can see here, or as you can see above, there was that whole row of numbers. But you'll also see that within the data set, we already have IDs already set. So there's already passenger ID right here, and there's already numbers assigned to all the different passengers. So it's kind of redundant having both of those numbering systems there. So in order to fix that, we're going to be using a function called setIndex. And basically what it does is, like the name suggests, it sets the index, gets rid of the default one that they put in when you first load the index, and it's just going to have everything numbered according to the column name that you specify. So as you can see, all you have to do that is you're just going to do df.setIndex, and then you're going to put the number, or sorry, no, the name of the column that you're looking for index. In this case, it's passenger ID, and then also in place equals true. So what you're doing here is you're giving the name of the column to be set as a new index, and then you're also putting in place equals true to make the change permanent. If you don't put in place equals true, like right here within the notebook, you'll actually see that it's just a temporary change. When you load it here, you'll see that passenger ID has been set as a new index, but if you load df again, you'll see that it still has that redundant default index on the side next to passenger ID. So in order to make all of those changes permanent, you're just going to put in place equals true, and then that way it's going to be within there permanently. And as you can see now, when we call data frame, once we put in place equals true, it's now permanent, and passenger ID is the new index. So yeah, it's circled right there, and we no longer have the old index. All right, next we're going to learn about indexing. And basically indexing is just kind of similar to what we did, except now that we've established how everything is numbered, we can kind of learn how to select different things in different parts of our data set based on those numbers and those rules of numbering that we actually learned in the last module when we were covering Python and lists. And that same types of principles are going to apply here. So kind of as a quick recap, indexing refers to the selection of subsets of data. So you have all this data available that's displayed right now, but a lot of times we're going to want to narrow it down to a specific type of data or data that fits certain criteria. So in order to do that, we're going to be doing something called indexing. And there's two ways you can do it. The first one is by using index numbers, so kind of using the index that we just set in the last step. And the second one is selection by column names. So it's going to be data selected based on the column names of data that we saw earlier. So the first thing that we can do is selection by index numbers. So in order to do that, we're just going to be using this command called ILOC, the name of the data frame, and then within square brackets, which columns we're trying to look at. So basically what this does is you're going to follow all of the rules of indexing that you learned in the previous module with Python. So for example, colon is still going to represent all of the columns or all of the values. And then everything is still going to be numbered from 0 to 1 to 2, except for passenger ID, because it's numbered already based on like index, it's going to be going by those numbers. But in this case, we're just going to be working with all of the columns on the side, and then we're going to be asking for only the information at survived, p-class, and name. And you'll also notice that when we call this specific subset of data, passenger ID isn't counted as a column. Because it's considered like an index on its own, it just doesn't count at all, and it starts from survived as the real type of data that we're looking at. So as you can see here, in order to select a specific subset of data based on like the index numbers, you're just going to use the rows index in the first spot and then the columns index in the second spot. So once you do it here, this is going to ask for all of the rows, and this is going to ask for the first, second, and third column of data. So here we'll see passenger ID, survived, and p-class, and name for all the passengers. But for example, if you wanted to work with a smaller subset like 0 to 4, you can get just 0 and 4 within there. Or here, 0, 4 will just get those like 0 and 4, so 1 and 5. Or actually, you'll also notice that, well, previously I said passenger ID is going to make all of the indexing follow the rules. Passenger ID is just for display or the indexing, but when it comes to selecting the actual data sets, it seems you still have to follow the rules where 0 actually is 1, and then all the numbers follow after that. So yeah, this will give you the first row and then also the fifth row. But for example, if you wanted all of them, you can do 0 to 5. Hold on. Work. Oops. All right, there we go. And then that will show you all of the first 5 rows and then just that type of data. A lot of times you might come across like a couple nitpicking errors within there, or like nitpicky errors. So for example, like earlier, you might come across a couple errors when you're putting in the types of indexes you want. But honestly, the best thing that you can do is just kind of test it out, see what works, and then keep going. And by the way, the reason why you're putting in up till 5 is because the indexing rules, as you'll recall from the last module, is that once you have a colon, it's going to go from the first value all the way until up to the last value, and otherwise it's not going to include it. So here it actually makes sense because based on passenger ID, it shows the 5th index, or like it shows this 5th passenger here as like it comes across as 5 on the actual like index number. But if passenger ID were not numbered this way and it was going from 0 to 4, or like 0, 1, 2, 3, 4, like previously as we saw, then using the ILOC and you only use it up to 4 would actually only go up to here through rows 1, 2, 3, 4, and then it wouldn't include this last one because indexing numbers is from the start all the way up to whichever last value you put. I don't know if that makes a lot of sense. I feel like I kind of complicated that. But yeah, just bear in mind the indexing rules from the last module when you're going through Python, because all of it is kind of like a puzzle that just keeps adding different elements. And then you're going to use all those elements together in order to work with your data. But yeah, if any of that like didn't really make a lot of sense, since I know I kind of like scramble my words, just let me know again in chat. But if not, I will move on. All right. So once you have the first type of method where you're just kind of basing it on index numbers, the next thing that you can do is you can also select by column names. So earlier you saw here that we're selecting them based on the numbers 0, 1, and 2. So you're going to get all of these columns. But you can also just get the actual text names of those columns in order to get the data that you want. So you can just use survived, sex, and age, and then separate all those within commas, within square brackets, and then that will show you all of the data available for just those columns. Either of them work, but in the end goal, or in the end, you're just going to still get all of the data for the data set, except you're restricting it to only those columns. All right, so now that we know indexing and how to select and only look at a specific type of data within a data set, the next thing that we're going to learn is how to drop and remove data. So as you kind of saw earlier, there is a lot of data within the data set that isn't actually available. So there's a lot of passengers that might not have information for like their cabin, or for some of them, even their age. So in those cases, there might be a time when you want to drop those rows so you can only have passengers with all the information available, or you just might want to drop like a specific passenger for whatever reason. And if you do feel like doing that, then there are two methods that you can use in order to do that. The first one is just the most straightforward. You're just going to drop whichever like passenger is at a specific index. So as you can see on the slides, you have df drop 3 and then in place equals true to make it permanent, but it's just going to drop whichever passenger was at the third index. So 1, 2, 3. And then it's just going to drop it at 3. So now passenger ID has dropped like 3, and then there, as you can see, there's a gap at 1, 2, and then it goes 4, 5, 6 instead. And then once again, just remember in place equals true, as that's going to make all the changes permanent. So that's kind of what we're doing as well here within the data set. But you'll see in this first time that we go through it, we don't put in place equals true, so it's not updated. But once we put in place equals true, that will make it permanent. The next method of dropping rows is going to be based on conditions. So for example, one condition that you can set is fare equals 0. So what you're going to do is you're going to use the same drop function as before, except within there, you're going to put df, and then within square brackets, whichever Boolean condition that you want. So for example, here, we put df fare equals 0. So now the condition is that if any of the passengers paid 0 or have the value of 0 for their fare, you're just going to drop all of those passengers and all of those data values for that specific passenger. So as you can see, once you put in df.drop and that condition and you run that, you'll see that our actual data set actually has much less values. So before we had 891 rows, but now, as you can see on the bottom, we have 876 rows. So we dropped like around 15 or so rows, or something like that, like 15 rows or 15 passengers from the data set. And then you'll see the same thing kind of within your notebook. So as you can see, once you drop fare, then you'll see that there's all of those columns that had passengers who paid nothing for their fare have been removed, and then the data set is smaller. And then after, there's another method that you can use that isn't actually using the drop function, and it's in fact just using the delete function. And the delete function for dropping columns is going to be like dropping an entire column of data entirely. So while before you were just, or hold on, I don't know if I skipped something. Yeah, I did. Okay, so earlier we were dropping rows or dropping passengers, but there's also different ways that you can drop columns, and it's going to be kind of following like similar principles as we did with dropping rows. So when it comes to dropping columns, that's you're dropping an entire category of data. So for example, you could drop name, you could drop the number of parent or children, you could drop all of that. So there are two ways. The first one is using the drop function again, except you're going to put columns equals, and then within square brackets, the name of the column that you want to drop. So for example here, we're just going to drop cabin since there's not a lot of information available. And once we've done that, we put cabin within square brackets and within columns equals, and then df.drop parentheses columns equals square brackets cabin is going to drop that column entirely from the data set. As you can see here, you can just drop cabin, and now we only have name, sex, age, SIB, SP, parch, ticket, fare, embarked. And you'll also see it reflects here. Now we only have 891 rows and 10 columns as opposed to 11 columns earlier. But remember, again, with the drop function, it only becomes permanent if we put in place equals true. So right here, it's not permanent, but if we wanted to, we would just put comma in place equals true, and then that would make the change permanent in the data frame. The next type of method we can use to drop a full column is the delete function. So you're just going to put del and then df column name, and that will basically do the same thing as before. Well, the only one thing that you have to notice with this is that the del function or the delete function is immediate. There's no in place equals true or anything that you need to type in. It's just as soon as you type del df, whichever column name you're working with, and you like run that code or press play in this instance, then it's going to instantly delete it from a data frame and it'll be permanently removed. So as you can see here, once you run del df cabin, once we call df again, cabin has been removed. We didn't need to put anything there, and now it's been permanently changed within the data set. Generally, I would recommend doing the first method first. A lot of times you may want to evaluate a data set, and if you'd like, you can delete the types of columns permanently. But if you're unsure of what exactly you're doing and you're kind of just experimenting, a good idea is just generally to use the drop function, as because it's not permanent, you can see what you're actually doing before you get rid of something. Okay. Next, we're going to learn how to drop NaN values. So NaN values are null values. If you'll recall, when we went over the info function, there's this thing called non-null values, which basically means any of the values within the function that are actually have information available to look at. So the null values is all of the information that you just don't have information for. So if you'd like to clean your data set, something that you can do is drop NaN values, which means you're going to drop any rows or any data or passengers with missing information in one or more rows. And there are three ways to do this. The first one is df.drop_na, and this is going to drop the rows where at least one of the elements is missing. You can do df.drop_na how equals all, which is going to drop the rows where all of the elements are missing, although df.drop_na how all is basically almost never going to be applicable, since if the data is in the data set, it's probably going to have at least some type of information available. But also the third way, which is df.drop_na subset equals columns, which is for whichever column you specify, if that information is null for that passenger, it's going to drop them. So here, this displays all of the different types of ways you can do it. The first one is df.drop_na. So it's going to delete all of the passengers or all of the rows where there's at least one element missing for any of the columns. So that gets rid of a significant portion, and we go from 891 rows to 711. The second is drop_na how all, which will basically take you from 890 passengers to 890, we forgot earlier that when we got rid of the passenger at 3, that turns the number of passengers from 891 to 890. So as predicted, the second method doesn't actually do anything. And then the last one is df.dropNA subset equals age, and that also gets rid of a significant portion, and we go from 890 to 713. And basically the same thing happens here when you're running it on your own within the notebook. DropNA will get rid of 700 or get rid of a significant portion. At least in the specific notebook, you can see that it's 712 instead of 711. I guess since we didn't run the delete function earlier, but that's fine since now we just have that difference to pay attention to. You also have drop NA, how all. You'll notice that it's still 891. And finally, like before, df drop NA subset equals age, and it's going to drop a significant portion. Okay, so once we've kind of learned how to drop values as well as only look at specific subsets of data based on index numbers or column numbers or whichever specifications that you have, the next thing that we're going to learn is how to analyze unique values. So within the data set, there's going to be a lot of times you're going to have a repeat of values. So for example, the most easy example is going to be the port. There's going to be only 3 unique values that are available there. It's going to be either S, C, or Q. But the same also applies for those numerical columns. For example, in passenger class, it's always going to be either 1, 2, or 3. So analyzing unique values is basically trying to figure out how many of those unique values there actually are. So in order to do that, you're just going to do df, the column within square brackets, the column that you're referring to, and then drop duplicates. And then once you do that, that's going to show you all of the different unique values that are available for that specific type of data. In this case, if you use df parch drop duplicates, that's going to give you all the different unique values for the number of parent or children and the first instance that that unique value shows up. So the first one is 0, so they have 0 parents or children, and then the last one is 6, so this passenger had 6 parents and children on board the Titanic. And basically what this does is it'll kind of give you the picture of what values are available for that type of data, and as well as the maximum or minimum if it's a numerical type of data. And you can actually even count unique values as well. So earlier we just used drop duplicates in order to get the range of unique values, but you can also use the 2 functions, the group by function and the size function together in order to get the number of times a specific unique value comes up. So in this instance, we're going to do df.groupBy embarked. So you're going to group all of the different parts of the data set based on whichever value they had for embarked. And then you're also going to use the size function to count the number of times that actually happens, or the number of values that actually fit within that specific group. So doing this, you're going to get first df group by embarked and then dot size, and then it'll return you the number of values available for each of those different ports within the embarked column. So now we know that 643 passengers, or the majority, came from Southampton. 168 came from, I think, Cherbourg, and then finally 77 passengers came from Queenstown. And then you can also tag sort values on the end like so. You're just going to do the same function, but add dot sort values, and then you'll have all the data sorted from least to greatest. So it'll go from Q to C to S instead of CQS by default. But kind of already, you can kind of look at how Python or working with Pandas and all that works. You're basically learning all these different elements, and you're going to add them together and keep building on top of each other. Because Python lets you get a result and then add on to that, here what we can do is we can just tack on 2 functions together, and the size function is running on the result of the first part. And then you can just keep adding functions in order to display the data how you want, in order to filter the data and do all these different things with your data set. Oops. And then finally, once we have gotten those two different ways that you can work with unique values, the last one is just nUnique, the nUnique function. So you're just going to put in the the name of the column that you're working with, and then nUnique, and then it's going to give you the number of unique values available for that column. So for example, df age, and it's going to give you nUnique 88. So there are 88 unique values in the age column. All right, so next we're going to talk about custom selections. So earlier we kind of selected the data based on like the index number or like whether or not they had a specific like column and you only wanted to look at those specific data. But we can also set other custom criteria to look at data that only specifies a certain condition. So for example, you can use the AFWhere function in order to select rows based on your custom criteria, and then also the AFLOC function that we used earlier to also look at a specific condition. The main difference is that the first one is going to fill all inapplicable rows with NaN. So like any row that doesn't apply to this condition, it's just going to have NaN for all of them. And then the second method is just going to drop any inapplicable rows and only display the rows that fulfill that condition. But as you can see, the first one is AFWhere. And then in order to do that, we're just going to use AFWhere and then this condition, which in this case is dfAge, is greater than or equal to 30. And what you'll see in the example is that we're actually like not only assigning the condition to a variable called filter, but we're also assigning the result of this where function in order to a new data frame called older than 30. And then once we call older than 30, you'll get back your custom data set, which has NaN filled in for all the values that don't have or all the passengers that don't have an age older than 30. You can do it on your own just by using df.where and the condition, but in this way, you can see kind of how we have our conditions and then actually filter down the data set to a new name and a new data frame that we can call again and further examine. The next type of method is using df.loc condition, and then you're just going to, again, work with your condition and give that a name if you'd like. You can also just put it in directly right here, but in this case, we're just naming it filter and then putting it in. But once you put df.loc filter, you'll see that it'll only show you the rows that have that condition actually applying. So as you can see, we have 2, 4, 5, 7, and 12, and so on, all as passengers that had age greater than or equal to 30, and then all of the rest of the rows have been dropped. And once again, you can check at the bottom of the data frame, and then it'll show you the number of rows and number of columns. In this case, it's 330, so only a small portion of the data frame actually had passengers with the data frame or passengers who actually had an age older than 30. All right, I'm going to take a second real quick to grab some water, so I'll be right back. All right, I'm back. So basically, where we left off, there is 2 ways, and you're just going to use the same type of principles for both of them. And you're just going to put filter as your like specific filter based on your condition, and then you're going to use either of those methods in order to look at your data set. Generally, most people are going to prefer the second one because doing so actually lets you see all of the passengers or rows that apply to your condition, And then the last one just kind of fills in NaN for any column that doesn't apply. Okay, so once we've learned these basic skills of not only how to clean your data set for values or types of data that just aren't of use to you, as well as to like create custom conditions so you can get a specific subset of your data that only applies to this condition that you've set, the next thing that we're going to learn is how to do basic analysis of those like specific data sets. So in order to do that, we're going to be doing something called aggregate functions. And these functions summarize and show us the overall properties of the data set. So remember earlier that we used the like info function to get like a summary of the columns, and we also use the describe function to get some aggregate values and summary statistics on all the numerical data. We can kind of do similar things using the aggregate functions, and we can get all these different like summary values for that data set. So we can get sum to get the sum of all the different values for that data set. We can get count for the numbers of those values, minimum, maximum, etc. So as you can see, we can just use those functions to get the values and kind of calculate what types of information you want. So in this case, for example, if you wanted to figure out the total amount of fare out of all these 891 passengers, you're just going to use df within square brackets fare for the number for the column, and then dot sum to get the total fare overall. And then you can also store that in a variable called total fares, and then that way, once you print total fares, you will get back the actual value. And you'll see that this will also apply for like basically any type of data that you're working with. So for example, if you did something, if you wanted to, for example, find out like the total number of like the total number of people who like survived, you could put df and then survived within square brackets, and then because 0 represents somebody dying and 1 represents somebody surviving, the sum would give you the total number of people who survived on the like Titanic, or at least within this specific subset of passengers on the Titanic. Oh, and actually we did it right here. So you can just use df survived.sum, and then you can use survived passengers to store that. And then once you do that, you'll see that 341 passengers survived out of the data set of 890 passengers. Another example you could do is like the number of like parent or children aboard or siblings aboard. There's going to be kind of overlap on there if like those passengers within the like data set or some of those siblings are also within the data set. But assuming like the data set is only comprised of like individual people and but not their family members, but just using that one passenger to represent anyone who's associated with them, then you could use that to figure out the number of parents or children aboard or the number of siblings aboard. Next, you can also use the max and min function. Their names are pretty self-explanatory, but you're just going to use the same rules as before. Use df and then within square brackets the name of the column you're working with, and then the max and min function to get the maximum value for that column and the minimum value. In this case, you'll see 512 as the maximum amount somebody paid within the data set to board the Titanic, and then the minimum is 0, so somebody paid nothing within the data set. You can also use mean, which is just the average. And for example, you can use df survived.mean, and you'll get 38.3% as the survival rate of people in the data set. Another thing that you could do is df age, and that will give you the average age. And then you could also do something like df parent children mean, or df parch within those square brackets, and then that'll give you the average number of parents or children that somebody had on board. Oops. Okay. And then next, we're going to talk about how you can kind of like combine these types of skills and then try to figure out more complicated problems. So you'll notice earlier, we're kind of just figuring out the basic information for all the data set using these aggregate functions, but you can also put the skills that we learned earlier together. We can use filters to get a specific subset of data, and then we can also use the aggregate functions and the other functions we learned to gather and make conclusions about that type of data that we specifically chose. So for instance, here we're asking to first filter and select the subset based on criteria. So again, we're creating a name for the filter or conditions we're using. The first one is that all of the passengers who had an age above or equal to 30. And then the second one is all the passengers who had an age less than 30. And then we name it filter over 30 and filter under 30. And then after that, we're going to create the data set based on our filter. We're going to use the LOC function, and we're going to filter over 30 and filter under 30 for each of those and give them an appropriate name. So now when we call DF over 30 years, we're going to get all of the data values or passengers who were older or equal to 30, and then DF under 30 years will give us all of the passengers who were younger than 30. And then once we have that, we can also analyze those specific types of information for those filtered versions of the data set. We can use DF over 30 years, survived mean, and we can find that the survival rate for people above 30 was 40.6%, but for the survival rate for people under 30, it was also about 40.46%. And that kind of shows us how we're beginning to draw conclusions using this data analysis. Based on this result, we can figure out that the survival rate between these two groups, between people who were older than 30 and people who were younger than 30, was about the same, about 40%. And then we can basically kind of extend that to other examples. For example, if we're going to use the group by function, we can get aggregate functions for like all that information based on a specific type of difference. So for example, we saw earlier that we used the group by function to get all those different ports and all the number of unique values and number of times that those specific groups came up. You can also do the same thing for different types of information here. So for example, we can use DF group by sex, and then it's going to separate all the information within your data and group them based on the different options they had for sex, which was either female or male. And then it's going to get the averages for all the different numerical data for those groups. So it's going to give you the survival rate, and we can see that there's a clear difference between female passengers and male passengers within the data set. We can see that 74% was the survival rate for female passengers, and for male passengers, unfortunately, the survival rate was around 19%. You can see the average age for female passengers was for example, 27.9, so around 28, and for male, it was 30.7, or around 31. So yeah, you can also see that in general, female passengers paid greater fare, so $44.5, as opposed to male passengers, who paid $26. And then once again, you can use that for basically any condition or any specification that you want. It doesn't have to be grouped by sex. You could also do group by port, and you could figure out if there's a difference between passengers who were who boarded from Southampton or from Cherbourg or from Queenstown, and you can also see if there's any difference between them. If, for example, one of those ports had more of a average passenger class, so whether or not passengers from that port were wealthier, whether or not there were more females or males in those specific ports or came from those specific ports, if older passengers came from one port or another, etc. Basically, by using those combinations of functions, you can try and see if there's patterns based on specific data. All right, so that basically kind of wraps up everything that you're going to learn within this module. By using Pandas, you can have and do a lot of things with your data. You can just load data sets from the internet. In this case, we're just using one that we found, but you can basically take any data that you want. You can clean the data to get rid of any values that aren't actually useful to you. you can filter the data and only look at like a specific type of data for that data. Or like you can only look at data or like columns that you want to look at. You can filter data to only look at like passengers or rows or any type of like data point that fits under a specific condition. And then you can also gather conclusions based on your filtered data and try if you can look for patterns or indications of anything within your data. Just by using this tool, you can like type a couple commands and you can gather all of those conclusions. And as opposed to doing it all on paper where you'd have to like go through all of that and filter the data and like print out things and do all of that, just by using code and being familiar with these commands, or even just having a cheat sheet on like your own where you're familiar with what types of commands you can use, you can experiment with your data, you can draw conclusions, you can look for patterns, etc. Right. So yeah, in this module, we learned to set indexes and index, so select specific subsets based on those indexes, to drop specific rows and columns, to drop null values or NaN values, to analyze unique values, to select rows and data based on your own criteria, and then to analyze using aggregate functions. There's also additional resources that you can go over when you're trying to go through the notebook, whether that's going through the notebook on your own and just running it through, or running through it, going through the Pandas cheat sheet that we have available. So there's just like a link with all of those different commands in one handy place. The glossary, so like just a bunch of definitions of terms. The notebook walkthrough, so another recording of like this tutorial. And then finally, this page with more helpful resources like links to the Pandas wiki, etc. And as always, don't hesitate to ask for help. So if you want to like look up things online to see how other people are solving coding problems, or just ask any instructors or anybody from Bit projects, all of those are great ways to solve your problems and get your code to work. All right, thanks for listening. Check us out on our socials here. And yeah, thank you guys. All right, I think I'm gonna end stream now. All right, thanks guys. I'm ending the broadcast.